Yeah. Okay. Yeah. Let me see what James. I've not. I'm studying for the CCNA now. I'm hoping to get CCNA by the end of the year. So you're on Kevin. You're in the same direction.
Yeah.
So Kevin is having she's having an exam next week also. Okay. Let's do this then. I was thinking because we're gonna do SPF today, right? And
Yes,
I'm
we're
still
gonna
thinking we
finish
do
that.
SPF today. Um. Yeah. Here's the thing. Let's carry on with OSPF. Um, it can probably lead to other studies, like maybe we'll talk about other things. Let's do this. Tu- 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 tu. Um, okay, I'll share my screen now.
Okay.
Let's go screen share, screen one. Let's go share screen. And then let's go this. Yeah, okay. You can see my screen, yeah.
Yes.
Uh, we talked about OSPF mainly like just the basics, foundations, and the theory parts last week. But I'm thinking this part, let's go step by step. Let's go. Let's go. Let me go. Um, mm, let's go. Let's go step by step, and the goal will be to configure OSPF and explain what exactly is going on with OSPF.
Okay.
So let me bring up my screen again. My GNS3. Okay. So let's put a topology of this one. Let's put one router, um, another router, and another router. And let's get ourselves a switch. And let's go 1, 2, 3. Okay. Sorry. GNS3 can't undo multiple clients. Let me see project. Stop. Mm, save project. OSPF. Okay, so let's go new blank project. Oh, okay, here we go. GNS3. And let's get ourselves router 1, router 2, router 3. And let's get ourselves a switch in the middle. Let's go router 1. Were you able to play with GNS3 at all?
I started, I downloaded, I haven't gone in it because I was like, I
Yeah.
don't want to run and start doing this now when I know I have my exam next week.
Yep.
So let me stick to the Eva that I know. So I'm sticking with now with the
Packet
packet
tracer.
tracer
Yep.
for now. And as I said, I also have the Boson, and
Yep.
that's with the
Yep.
that simulator that they gave me to answer those questions, those
Yep.
practical stuff that they gave me. I
Yep.
feel okay with that.
Yep. Let's go switch parts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
But the thing, one of the things that I have a problem with is when you, like, you do a show command and you get some readouts.
Yep.
Some of the stuff, I'm not sure what they stand for. And I know I wrote down a question.
Yep.
I found one.
Yep.
No, it was another one. It was about the readouts, and I wasn't sure because they'll normally ask you,
Yep.
what does so and so mean? I know what the MTO mean,
Yep.
but there was something else that I wasn't quite sure about. But as soon as if anything, I'll email you or
Yeah,
within the
that'll be
week.
good.
But it's something like that.
Yeah, that'll be good. Let's go. We have this router here. Um, go down here. Get our interfaces right. Hello, Powell. Hello, Powell. How are you doing? Yeah, so we'll also discuss like especially like we'll do the show command for OSPF. We'll discuss
Yeah.
that a lot today. Let's give it
Okay.
some. Let's go 10.1.100 dot 0/24. And let's go this O1. Let's call this 10.1.200.0/24. Now on this router, let's give it a loopback address 10.1.1.1/24. Let's call that loopback 1. Let's have a loopback here, and let's call it loopback 2. It's 10.1.2.1/24. Okay, and let's go loopback 3. 10.1.3.1/24. So we have 3 loopbacks. We have routers there. Actually, we don't need to label the switches. Let's delete the switch part.
Could I ask you a question while you're
Yeah.
doing all of this? Okay.
Yeah. So it's just to label everything, so we know what we're doing,
Yeah.
what we're working with
No
today.
problem.
Yeah. So
All right. When the OSPF
yeah,
it's choosing the designated router,
yeah.
it uses the highest IP address, right?
Yeah. We'll talk about that. It does. It uses the ISIP address. But which ISIP address do you mean?
All right. So say for instance you have 192.168.1.1 and the next IP address is .1.2.
Mm-hmm.
Which would be the designated address? Would it be .1
It
or
depends.
.2?
It depends on that. It depends on a lot of things. It depends on a lot of things in terms of like the designated router and the backup designated router. And let's call this one dot one. Let's call this one dot 1.2. Yeah, so we'll talk about that one today. Because what we'll do today
Okay.
is we'll go step by step
Okay.
through all the process and explaining what exactly is going on. So let's call this dot 3. So this is network topology that we're working with today.
Hmm.
So much like this. Yeah, let's go try to expand it some more. Dot 2 and dot 2, yeah. Dot 1 here.
All right. So which one is router? Oh,
Dot
so
2.
router 3.
Yeah.
Router,
This one here and this one here. Okay, and this area we'll call it area 0. So that's what we're going to be working with today.
okay.
Hello, Powell and Shane, how you doing? I think you're muted. You can unmute yourself. Powell and Shane. Shane, it's been a long time. How you doing, man? Yeah, maybe they're having problems with mics.
Okay.
Yeah, Powell. Yeah, you guys having problems with mics. Okay. So what we'll do is we'll go step by step through this one. Let's start everything. And we're going to be using our good friend, what we mentioned last week. We're going to be using Wireshark also.
Okay.
So Wireshark will be helping us because we're going to be doing some capture to try to understand what exactly is going on with OSPF. So let's go to, yeah, I think I may need to delete the big circle. Yeah, here we go. So let's start capturing this one. Let's,
A question with Wireshark. When you just type in the IP address right there, you don't have to go into configure to.
sorry. Oh, you mean, no, so it works differently because
Oh,
they've integrated it into this one. Because normally when you start Wireshark, it's going to ask you which interface on your computer, which network card do you want to capture packets on. Yeah, but it's a bit different in this one, in that they've integrated it into GNS3. So that's the reason why it's asking you, says select the port that you want to capture traffic on. So I just go ahead and
yeah, I
select it.
understand. I understand capturing the port, the information. But what I was asking is,
Mm.
just like how you type in just the information with loopback and so forth,
Yeah,
don't you have to go in and go into the router itself and configure that loopback?
yeah, we will definitely.
Oh,
We
okay,
will. Yeah,
okay.
we will. Set, apply. Okay, trying to start Wireshark now. Um, need to go copy. Just make sure that I've got Wireshark in that location. Ah, yes, we do. So what I can probably do is get rid of this one. Ah, here we go. Mm, and if not, yeah, we'll probably just continue if that doesn't work. Let's go
Okay.
back to packet capture, yeah, because I think additional capture set and go, okay. Oh, okay, here we go. So this should be okay. So this is how to um, start Wireshark. Yep. So now let's start Wireshark here also. And let's start Wireshark here also. So since Kevin is the only one that has a mic, others can also you can type to join in. But what we want to do is we're gonna go step by step and we're gonna configure OSPF for this network.
Okay.
And you're gonna be the one guiding me as to what to do. And what we're gonna be doing is what we're gonna be doing is as we're configuring it, you'll be explaining exactly what is going on. So
All right.
So first step, so now you're a network engineer. Your goal is to configure this network so
Mhm.
that the guys in this this, this branch office here can access network resources in this branch office here, and the guys in this branch office here can access network resources in this branch office here. Um, that's the goal. But then let's go to okay. So here we go. So what's the very first thing?
Configure the routers and then and then start running OSPF.
Okay, so let's configure the routers. By configure, I guess you mean configure the IP
Put in the
addresses.
IP addresses, right?
Okay, so let's,
Interfaces, configure the interfaces.
yeah, so let's bring that up. Um,
Sorry.
house. Let's go how1. Okay, here we go. So we have this one here. So how1, if we go, yeah. So if you guide me, so I'm configuring how1 now. So which one do we like me to configure first?
R1, you're on R1, so you can go to the interface 00.
Interface. Actually, let's do this. Um, do you have TeamViewer on your system?
I should have it.
Yeah. So if you have
Are you gonna
TeamViewer,
let me log in to do this?
yeah. So let's log in and do this. Um, Shane, I can hear you. What's going on? And JM also. Okay, well, JM has no mic. JM, do you have TeamViewer on your system?
Okay. What do I need? I need your.
Yeah, ID and the password. So let's
Okay.
go
What's your
remote
ID?
control. Yeah, there you go. So that's the ID there, and that's the password to use on the screen.
Okay.
You can download it for free, JM.
Could you move that so I can see the password?
Yeah, Google. Yeah, so you're logged in, right?
All right. So I guess we're gonna get some feedback.
Yeah. Yeah, okay, yeah.
Okay.
So go ahead. So if you configure router 1, so if JM can log in, JM can configure router 2. And if Shane can log in, Shane can configure router 3.
Um.
So look at the network that it's on.
Okay.
Let me help you move this out of the way, sorry. She, yeah, let's move this out of the way. Yeah, carry on. We can carry on now. Sorry.
Okay.
So the IP addresses of the interfaces, they are on the interface. So router 1 is not dot 2. So
Huh?
router 1 is not dot 2. So the IP addresses are the ones
Isn't
on
that
the
the?
they are the
I
ones on
thought
the
this was the IP
interfaces.
address.
So that is router 2, but you're on router 1 now.
Oh, I'm on router. Oh,
Yeah.
I'm sorry.
10.1.200.
Mm. So what's the IP?
Yep.
I
So
don't.
so there's dot one here. So that means dot one means dot one for
Yeah,
that network.
but I don't see any network or I can't
So that's the
see.
network here at the top there, 10.1.200.
Oh, this is the same.
Yeah.
Okay.
So let me minimize this so you can see. So if I take this one away, so if you look at
Oh
this, so
yeah.
all these they are all connected to the switch. So they are
Yeah,
all
I
on this
realize.
network.
So
Yeah. So let me bring this back now. Yep. And we can continue. Um.
yeah, that's better.
Yep. Okay. There we go.
What's which one is the DC?
Oh, okay, yeah. So that's router one.
Yeah, but which one is the DCE? Which router?
Router one. Router one is the one. Yeah.
What's what's the clock rate?
Yeah. So just give it 64,000.
Okay,
Before
there you
you
go.
exit, if you go back under that and give it a bandwidth of, so if you go back, go under
Okay,
interface serial 10, and then, yep, bandwidth command.
bandwidth off.
Yep. So if you do question mark, yeah. So if you give it a bandwidth of 64 kilobits, do you know the, no, not, so don't give it 64,000, just 64 will be good.
Okay,
So it says bandwidth in kilobits. Do you know the reason why we're giving it a why we're saying bandwidth, or we're manually putting in bandwidth 64?
no,
Yeah. Does anyone know the reason? JM, what do you think? JM, have you found TeamViewer at all? JM or Shin, what do you think? Why are we manually putting in the bandwidth here?
GM said beyond my scope. Okay, bandwidth has something to do with the speed rate at which it sends information.
The main reason why we're giving it bandwidth, so yeah, yeah, your answer is close. So the main reason why we're giving it a bandwidth is because when we start discussing OSPF costs,
Hmm.
so because otherwise OSPF is just going to know
Oh.
OSPF is going to use the default bandwidth of the interface. So this
Hmm.
interface can probably support more than 64 kilobits, but we actually want to force it to use 64. So that's why we're manually entering it here.
Okay.
Yeah. So what's the next thing that you configure? You need to configure the loopback also.
Oh, I don't know how to do that.
Yeah, it's simple. JM, you want to help Kerry to configure loopback. So how do you configure loopback?
I know it's a logical interface
Yeah,
that can never go down,
yeah,
but I've never configured one before.
yeah. It's simple.
So,
It's the same way you configure your interfaces. So just go
so,
interface loopback.
so do I go to int?
Yeah, just go interface, then put a question mark.
Mhm. I'm clicking, but okay.
Yeah, there you go, loopback.
Okay.
Then you give it the number that you want. So if you put a question mark after loopback, yeah. So it says it needs a number. So we've given them numbers. So we said router
Loopback
one is
one,
loopback one. Yeah, yeah.
and
There
then
you go.
that's it.
Yeah, and then
And then I just put in the IP address.
yes.
Okay. And do I have to open the interface?
If you look at it, the moment you enter the interface loopback one, what did they say? It says it changed
Um,
state to hop, right?
oh,
It
yes.
didn't go down again. So
It's already
yeah,
up.
yeah, it's up by default.
Okay.
Okay, so now we've configured router one. So now
Yes.
router two is at the top. So just change your tab to router two.
So I'm doing everything?
Yeah, because because JM is not getting team viewer and Shane is not talking. So if you go ahead
Okay.
with router two, I'm not sure why Shane. Maybe Shane is not hearing us or something. Yeah. You forgot something.
I was gonna do the loop right now.
You forgot something on the serial. A clock rate. Oh, sorry, clock rate comes
I
from
did
the
the clock
ZTE.
rate already
Oh,
for
okay, yeah.
oh.
Sorry, cause that's ZTE. Yeah, sorry. Sorry about that. So yeah, the loop back. Yeah, that's so yeah, good one. Oh, Shane, Shane, Shane. Oh, did I just take over your mic? Oh, sorry, sorry, sorry. I just took over. I wanted to reply Shane. Carry on what you're doing.
Okay.
Yeah. So Shane was typing. I wanted to take over and quickly type a reply to him. Oh, Shane, why did you move to Windows 10? Why? You can still download TeamViewer. JM, come on, TeamViewer is not difficult. Oh, okay. Oh, I see what you. Oh, sorry, JM. Yeah, I see what you mean. You're at work. Okay, how to. Yeah, so you go how to configured. So let me do the configuration of how3, and then we'll move to OSPF. So how3, all we need to do is configure. So if I go interface.
So
F00.
Windows 10 is awful, Shane.
What?
I was asking Shane if Windows 10 is awful. I'm not
Well,
a Windows fan.
what do you that's true. What do you think of Windows 10, Shen? I tried it like when it came out. I just installed it on a VM to just play around with it and see what's going on with it, and I wasn't too impressed.
I'm a Mac person or Linux.
Why? Mac the factory IP address. Then that Max, oh God, Max. I do have a Mac, but I'm not. I'm not like a fan of Max at all.
Really?
No, not at all. I'm not even close to being a fan. I know they make quality stuff, but it's not just quality stuff. For me, it has to be compatible with lots of things.
So that's why with my Mac
Yeah.
I have parallel desktop
Yeah.
with Windows.
Yeah.
So if it can't run in Mac, I always have my Windows section,
Yeah.
but it has to go through Mac. So hey,
That's like a good idea. Yeah, because I remember first time because when I used to stay in London, I used to travel almost 2 hours to get to work every day, and I was like, yeah, I'll just do some reading on the train, and then I was like, yeah, I'll get a tablet to help so I can just watch my videos, read my books on the train, and I told my friend, I said, let me borrow your iPad for a few hours. Let me transfer my videos on them and just see how it works on the iPad. And then I could not transfer my video to it because it wants me to transfer it to iTunes, and then to transfer to iTunes I have to convert it to this one, and then it's just like a long process just because I want to watch a few videos on a tablet. Then I went and got the Samsung Galaxy and I just copied the videos over, and it even did the conversion for me. It did the conversion and the compression of the video for me, and I'm like, why do you have to make your thing so closed that it's just so difficult to use? Like, ease of use is big to me. Ubuntu talking Linux now, eh? Shit. Okay, so now we go. So here we go. So now we've got all. So let's just make sure we can ping all interfaces. So is there a quick way for me to ping all the interfaces? And
yeah, ping. Oh, I
yeah,
don't know, ping.
not ping, not just ping, because yeah, we can do ping. What about Shane? What do you think? Is there a way? Is there a way? Have you ever heard of this thing before? TCL.
Hmm.
So you probably see, but yeah. Look at this TCL. If I do a question mark and let's go down to TCL. So just so that you are aware that something like this exists where you can script on the Cisco shell. Look at this. TCL SH, two command language shell. So this is
Mm.
scripting, this is doing scripting on the Cisco shell. So I can basically go TCL shell and go for each um, and then give the addresses I want to ping. So I want to ping 10.1.1. Sorry, I want to ping 10.1.200.2, 10.1.200.2, and 10.1.100.2, and 10.1.200.3. And then close my bracket, and then and then go ping address, and then press enter. And there we go. Yeah, and it's done. So that's a way. So basically, yeah. So it's just, I mean, just look up on Cisco when you have the chance. Just bring up Google and look up TCL shell. I think I even have I have it open here somewhere. If I go Cisco TCL SH, yeah. So it's a way to do scripting. Oh, oh. Hello? 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 Hello?
Hi.
Yeah.
Yes, we lost connection.
Yeah, sorry. Yeah. So I'm not sure if you saw the last part of that.
No, you have to go
Okay.
back through that.
Yeah. So if you connect to the team viewer again, so let me bring that up again so you can connect to it. So that's the ID and that's the password. Mm, mm. And Shane, you can still try to connect. Without the mic, you can still try to connect. So can you see the ID and the password?
Nope.
Oh, okay, sorry. Oh, I'm not even sharing the screen. Yep. Mm, yep. Okay. There we go. So yeah. So what I was saying was that the quicker way, that we're saying the quicker way to just do is you can use the TCL shell, and you can use, like, for example, what I did, like, for each address. So it's a way to do scripting on Cisco shell. 10.1.200.2
Hmm.
is one address I want to ping. 10.1.100.2, and I want to ping 10.1.200.3, and then goes I go ping variable address and enter, and it just goes and runs the script and pings everything I want it to ping. So that's a quick way to
Okay.
do it. Yeah.
So is this available on all routers
On newer ones, at
or
least from 10,
on the new
sorry,
ones? Okay.
from 12, from version 12 of iOS, you'll find that available. So yeah, if you go online and just search for Cisco TCL Shell, TCL SH,
Okay.
Cisco, yeah. But yeah, that's just so you're aware that something like that exists. So we go exit. Okay, so now we've configured this. So the first thing we want to do is we want to start configuring OSPF now.
OSPF.
So what's the first thing that would do, and what will be the impact of that?
You start running OSPF so that the routers can start sending hello packets.
Okay, so first thing we'll do, um, start running OSPF so that the routers can start sending hello packets. So is that true? Do you agree with that, Shane? Shane, do you agree with that? And JM, do you agree with that? So Kevin says the first thing we'll do is we'll start running OSPF so that the routers can start sending hello packets. So that's what Shane
Yes,
says. That's what. So JM says yeah. How about you, Shane? What do you say? Do you agree?
he said it.
JM says yes. Shane, oh, Shane, what do you say?
Jim said yes, and Shane said yes.
Oh, Shane. Oh, okay. So here's the thing. I don't agree. I don't I don't agree with that. That's the very first thing you do. Because you start running OSPF so that the routers can send hello packets. That's not the first one. That's
But
like still way down.
but
Hmm.
hold on. When you start configuring
So which commands do
OSPF,
you
you
which
have to
command?
say
Sorry, carry on.
OSPF on the process number, router OSPF on the
Good one. So that's the command we start. Router
OSPF
OSPF and
and the process
process
number, whichever number you
number.
want to
So
choose.
you're right. You're absolutely right. But what
But
does this command do?
that starts running OSPF,
It starts running OSPF, but what about this part?
and then you have to apply it to the interface.
So let's go down. So let's put this on number 2. So this one, so the first thing we do is we start running OSPF, but it doesn't start
hmm
sending a low packet at that point.
I think once you start the router OSPF with the process number,
Yeah,
I thought it automatically starts sending
sending
out
hello. Yeah, let's see that.
alert.
Let's see GNS3. Only that GNS3 is messing up today, and it's not capturing packets properly that we want it to. So if I go, sorry. Uh-oh. Serial 10 to serial 10. Yeah, didn't mean to delete that. Okay, so if I go start capture,
Don't you have to reconfigure?
no, no.
No?
So the
Okay.
configuration will just still be there. So hopefully, so if I go, let's go
But
to
we didn't start running the
OSPF process.
OSPF
Yeah.
yet.
So if I go, well, with I want, so if I go ping 10.1.100.2, yeah,
Okay.
I wanted to see whether it's gonna whether it's capturing anything, but it looks like it's not capturing anything at all. Come on, stop capture, start capture, just start capturing. Yay, here we go. We're back in
Okay.
business. So that's capturing. So let's capture this one too. Um, let's go stop capture. Let's go start capture. And here we go. Is it? Are you capturing anything, please? Let's go back to our router. So the reason why I want to see this is if I do ping 10.1.200.3, this one is not capturing anything. But if I go stop capture and then go, because I want us to go start capture. Here we go. So it's, yeah. So I just need to stop capture and start capture on all of them. Stop capture completely and then start capture on that one. Yeah, no, doesn't like that. Let's stop capture, start capture. Yeah, there we go. So, and then the last one, let's stop capture, start capture. Here we go. So now the one that we want to monitor router one. So we want to
Okay.
monitor router one, this interface, how one or this one, whether S10 or F00. So that is this
Mhm.
one. So router one, fast 00. So this is all the packet that's going out. For example, if I should do a ping now, we should see the ping go out and come back. So if I do ping, or maybe not through that one. Let's do ping 10 dot. This is fast internet. Mm, yeah, still not capturing properly. Um, yeah, Wireshark, sorry, GNS3 is messing up today, unfortunately. Yeah, but we can still use another method apart from GNS3. What other method can we use? We can use the debug. So
Oh.
let's do debug IP OSP.
But we didn't put OSPF at all on this.
Yes. So that's why. So we've not put OSPF, so we've just turned up, switched on debugging, so that when OSPF starts anything, um, we can start picking it up. So now, if you go ahead and switch on OSPF on this router, so go ahead and switch on OSPF on it, and then router OSPF, and then just give it process number one, yeah, and press enter, and hold on.
Okay.
Now nothing is going out because if something was going out, we'll have seen it. So
Oh.
now OSPF is on, but again, Wireshark is not working, but we have debugging running. But
Uh-huh.
OSPF is on, but it's not sending anything. So back to the slide, you're right in that the first thing we have to do is start running OSPF, but it's not so that the routers can start sending a low packet because that's still down. So
Okay.
if it is not for the purpose of for it to start sending a low packet, so what has this command accomplished?
Get the router ready to say that you're going to be using that routing protocol.
Yeah, that is right. But how does it do that? Like what is it that has gone on? So we go to the router, we enter router OSPF 1, router OSPF 10. It does something. But here's the thing that it does. Look at, we'll see what it does. So now we're back on the shell. If I go back and go IP, show IP protocols, important command. Show IP protocols. It shows us, well, router protocol OSPF1 is running, right? So we
Yes.
have it running. But then if you look down, you see something here, router ID. So that's the first thing we'll mention. So the moment we come here and say router OSPF1, the first thing the router does is the router selects
The
something called
designated router.
a router ID, not designated
Router.
router. So that one is still down. So the very first thing it does is I have to select a router ID. What is the router ID?
The unique number for the
You're right.
router running OSPF.
Yeah, you're right. It's just an identification. For example, this router, if you go back to our network diagram, this router has two interfaces, right? Even three interfaces. It has
Yeah.
interface fast 00, it has serial 10. Now, this one has an IP address, right? This one has an IP address. So how do we recognize this router in our OSPF infrastructure? There must be a way for us to recognize it because otherwise there's going to be confusion if we can recognize it with the IP address of this one or we can recognize it with the IP address of this one. So there must be a stable address or stable name, sort of, that we can use to identify this router in our OSPF infrastructure.
Okay.
So that is
And that
called
is
the
what.
router ID. That's the very first thing it does. It's like now you started OSPF, I have to select a router ID for this router that I'm running on. And what does it use to select the router ID? I know there's a lot of
IP
information to carry in here. You may not be able to carry in anything at once, but just keep listening. So you start running on SPF. It's like, yeah, I have to select the router ID. It has to go through a criteria to select the router ID.
use the lowest, the highest IP. It uses the IP address.
Yeah, it does. JM, what do you think? And Shane, what do you think? What does it use? So Kerry says IP address. Which IP address, Kerry?
Mm. Well, I don't know. I was about to say the MAC address. I don't know.
Static. We'll see it together. Static router ID command. Or number two is highest loop back IP address. Number three is highest physical IP address. So that's the thing it does. It's like, is there a static router ID command that is available on this router? If there's a static router ID command, that's what I'm going to use for the router ID.
That means that the static router ID command is when you manually
Enter it.
choose the. Okay,
So let's do that now. So how do I do that if I want to do that? Let's say I want to enter a static router ID.
go back into
Yep.
route config,
Conf T.
then router OSPF
Yep. Router OSPF 1.
one.
Yep.
Mm-hmm.
Then what?
ID RID, I think.
Router ID.
Yeah.
Yeah. So you're right. So that's it. Router ID. And then
Put the
question
question
mark.
exactly
Say
because I don't know
OSPF
what.
router ID in an IP address format. So let's say, so now when we did show IP protocols, it says this router ID is 10.1.1.1. Let's say actually we want this router to be 1.1.1.1. So we go 1.1.1.1 and we'll go enter and then end. And then let's do show IP OSPF protocol again. Oh, sorry, not show IP OSPF protocol, show IP protocols. Can you see that?
Yes.
The router ID is now this. So when you switch on OSPF, the first thing it does is I have to select a router ID. There must be a way for me to uniquely identify this router in this whole infrastructure. So it's either you manually configure it, that's the very first thing it does. If you've not manually configured it with this command, then it goes to the next one. Is there any loopback interface configured? If there is any
Yes.
loopback interface configured, what is the highest IP? That's the one I'll use. So let's say in this situation, let's go back to conft and go router OSPF 1. How do I remove the router ID? I just go,
No.
yeah, good one, no router ID, and then we're done. And then if I go back to hand and then show IP protocols again, now you see it's changed back. It's now 10.1.1.1. Now let's bring up our network diagram again. So we have a loopback interface here called 10.1.1.1, right?
No, that's 10 dot.
That is
Yes, that
why it
is
is using
10.
this because that's the
Oh,
highest loopback. We only have one. Let's say we go back to our router now. Let's go back to our router and I say conf and I go actually let me have another loopback called loopback interface 10. And this IP address of loopback interface 10 will be 192.168.1.1, 255.255.255.0, and sorry, interface loopback IP address. I forgot to put address. IP address 192.168 and press enter, and then go and show IP protocols. Yeah,
it's the
so
same.
yeah, it's the same. Yeah, good one that you even it's the same. Why is it the same? Because now what we've said is that it has to be the highest loopback interface, right? But now we
Yes.
have a new loopback interface. So let's duplicate this. We have a new loopback interface called loopback 10 that has an IP address of 192.168.1.1, which is higher than this one. So how come it's
I
not?
right. That's my question.
Yeah. So how come it's not
Ah,
the new router ID now? It's because many times this one will not give up that address until you restart the OSPF process. So it's going to hold on and say, well, I'll still keep using this router ID until either the router reboots or you restart the OSPF process. How do I restart the OSPF process on this router?
um, config T.
It's this one, clear
Uh,
IP OSPF process. Clear IP OSPF process will restart OSPF on this router. So it's like you restarting a service on your Windows machine.
question.
Yeah, carry on, please.
If I had gone to the configuration mode,
Yeah,
configuration terminal,
yeah.
and then put no router OSPF, would that work?
Yeah, it will work, but now
Oh, okay.
you've given yourself multiple work because now you have to
Oh,
reconfigure OSPF again. Let's say when you've configured OSPF, let's say you've already put in about 10 network statements.
mm-hmm.
If you go to no router OSPF, you've basically deleted that from the config, including all your network
Okay.
statements. So now you have to start configuring all your network statements. But this
Oh,
one is a way to say just restart the OSPF process. But here's
okay.
this one. You never, ever, ever, ever do this in a production environment.
So don't
Because
teach me that way.
no, there's a reason why we'll come to a conclusion here. We're building on something. We'll come to a conclusion. But you never ever. Why do you think we don't do this in a production environment?
You have things
JM,
will
what do
start
you
going
think?
down.
Exactly. Because you do that, you know what it's going to do? It's going to discard all your OSPF routes. It's going to be a now I'm a brand new OSPF router. I have to start relearning every topology. I have to start relearning everything from scratch. So that's what will happen. So basically, it's going to tear down everything. It's going to forget about all the neighbors, and it's going to say, now let's start learning about the network again from scratch. So if I go clear IP SPF process, Cisco are smart. They put a warning to say, are you really sure you want to really do this? So I say, yes, I really want to clear that, and I present that. Now, if I go back and say show IP protocols,
It's still the
let's
same.
see if I go show run, what is my loopback? Did I really configure that, that loopback? 192.168.1.1. Let's go interface loopback 10.
Yes,
Yes, I
it's
did.
there.
Yeah, I did. Um, so wait, is this a bug in GNS3? Um, yeah, because that's supposed to take over because the IS loopback interface should become the router ID. So let's do this. Um, let's do let's save our config. Let's save our config so we don't lose anything. And then let's reload the router. Um, mm, yeah, so let's reload the router. So not. Okay, so let's reload it. So while it's reloading, let's come back. But that's the way it works. So the way it works is you have this either the static router ID command, if you configure that. If you've not configured that, then it goes and says, am I configured with any loopback interfaces? If I am, which one of them has the highest IP address? And it goes for that. If there are no loopback interfaces configured, then it goes to which one is the highest physical IP address. So let's go back to our diagram. So in this situation, let's say we don't have these two loopback interfaces. Which what do you think the router ID will be for this router?
10.1.200.1.
Do you agree, JM and Shane? Do you agree with that? So if we don't have this loopback interfaces, what will be the router ID? Kerry says 10.1.200.1. What do you say? Yeah,
Shane
you're right.
says
Yeah,
yes.
you're absolutely right. So that will be because it goes in that process. And do you now the other question I want to ask? I thought I confirmed it. Um, tu- 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 uh, oh, I hope it's not hanged. Oh, yeah, something strange is going on.
Is it because I'm connected?
No, I don't think so. I think GNS3 just decides that today is gonna be my day to be to have a quiet day. Yeah, let's. I'll probably just close this and just go back to the console again. Close. Console. Ah, yeah, okay. It's done something. One in VM is not running. Will be unresponsive. Oh, what are you doing? Let me just go stop and let go start. Quick one. There we go. And then change settings, appearance. Let's make that bigger. Nice. Okay. So that's the process it goes through. So now we'll just confirm if that comes back and works as it's supposed to work. If not, that's still the normal process that it goes through. Probably something wrong with. So if I go show run to just make sure that all my configuration is still there. All our configuration is still there. Yep, everything looks good. Do we still have a loopback interfaces? The loopback interface is there. Serial. No, we don't have them.
I don't see it.
So yeah, so show IP protocols. Yep. So we have to go back and go router OSP. Let's go interface loop back one, right? And we
Mm-hmm.
had IP address 10.1.1.25.255.255.0 and then let's do interface loopback 10 and let's give it 192.168.1.1 and then go enter and let's go with OSPF 1 and then let's go back and show IP protocols. Yeah, there we go. So now you see the one that is selected for the router ID, the highest
Mm-hmm.
loopback interface. So that's how it works. So it selects the highest loopback interface. So now if I go and let's go conf3 and let's go no loop one, sorry, no interface loop one and no interface loop 10. So we deleted all our loopback interfaces. And then if we go to hang
Mm-hmm.
and let's confirm what's the so for some reason it's still like hold on to that. That's still my the let's clear IP OSPF process. Yeah. Sorry. Let's show IP protocols. Yeah, it's still holding on to that. Maybe it will reload it or something. Yeah. But you get the
Mm-hmm.
point, right? You understand the point?
Yes.
Yeah. So now, if we were to restart it normally, it should select the highest IP address of the physical interface as that. So, is this important in your infrastructure? If you're a network engineer, is this important for you to make sure that you have a static router ID? Is it important?
Yes, it's important.
Why? What's the reason? So network engineer Kerry, well, why? So you're in a room with your colleagues, with your other network engineer colleagues. So they're like, yeah, Kerry, we'll give you the task of configuring, this part of the network for us. and you're like, yeah, part of the things that I'll be doing, because you have to do, you have to get peer review with your colleagues, and you're like, yeah, so part of the things I'll be doing is I'll make sure that this one is the voter ID for this voter, and you're like, what are you doing? You're wasting your time. So how
You
do you
need that
how do you convince all these tech guys and say, no, no, I'm not wasting my time. This is really important stuff.
because you can. It's the router ID it uses to identify the designated router,
Yeah, that is true. That's absolutely true. It's the
the
voter
backup
ID that
designated
yeah,
router.
so it's part of the thing that it's not the only thing. It also has its own
Right.
process that we went to. But that's part of the thing that you use. But is there any other reason that you want to? Maybe they're like, yeah, who cares about the backup designated voter or designated voter anyway? Tech guys can be really tough. I tell you. Have you ever been in a room, in a meeting room with tech guys ever? Like with lots of them when they're discussing and planning for projects and all that stuff.
Not lots of.
Ah, yeah. What about you, Shane? And tech guys, I tell you, tech guys were among some of the most egotistical people. And I tell you, they will challenge you on everything. Yeah, seriously, you have to be convincing because they will challenge you on everything. I mean, I stay in every Monday morning and Monday afternoon is like a team meeting, and you can basically just feel the ego in the room. Because everyone is an expert, and I tell you, people will come after you on everything. So you have to be really strong and make sure you justify every single thing, which is not like bad, but I tell you, IT people will challenge you that you're just wasting your time. It's not something that much important. We can be spending our time on something more productive and more useful than worrying about router IDs and all this stuff. So one of the reasons is this. As you go higher in OSPF, there are some configurations that you can do. Like for example, you can say to router 2 and say when a router ID, when an OSPF router with this router ID comes to you, yeah, this is what you should do. Now, if you have that kind of a configuration on your routers, or if you're going to use it in the future, you have to have a really static router ID, right? Because otherwise, let's say you configure 192, maybe you configure this one, maybe you configure a loopback interface there. Then maybe a network engineer comes one day when you're not in the office and is like, yeah, let me just do a quick test. Let me create this loopback interface and create, this loopback interface quickly, and that becomes your router ID. And all your configuration is broken because you specifically told your other routers, if a router with this router ID comes, this is what you do.
Okay.
So that's why Cisco will recommend you to always use this one to manually
Okay.
set it. So as a network engineer, you always want to be in control of what's going on your network. So yeah, so that's the first thing it does. So now we've beaten that horse to death. That the first thing you do, you enable router OSPF process number, and the very first thing it does is like, yeah, I'm gonna select a router ID to identify myself, and it goes through this process. Do I have static router ID configured? No. If I don't, IS loopback address, no. IS physical address, then it picks the, and then off we go. So if we go conft, any question regarding that before we go on to the next one? Conft interface, let's just go. Any question regarding that? Done. Interface loopback one. Let's, I give it its proper IP address again. Yeah, okay. So the next thing that we'll do, so after we've done this, so what's the next thing that we do? And what's the
Ap-
impact? What does it do?
Apply it to the interface.
Apply to the interface. Apply what to the interface?
The OSPF and specify the area.
Apply OSPF to the interfaces and specify the area. So you're right. So how do we do that?
Mm,
How do we apply OSPF to the interface and specify the area?
IP OSPF.
IP OSPF
something area or zero.
Something zero. So Shane, do you agree with Kerry? And JM, do you agree with Kerry? So we have Shane, come on. Shane said, no, I don't agree. So Shane, come on, you have to give me your own command now. So what do I do? So Shane, so Kerry is right. She got this right. We have to apply OSPF to the interface and specify the area. So that's the very next thing we do. But how do we do that? So Shane, what's your command? And GM, what's your command? How do we do that? How do we do this second one? How do we do this second one? Shane, GM, can't keep quiet on me now.
Network
Network,
and the network address
network address.
and mask
Shane said, I'm not sure. But you're sure that it is not the first one that Kerry said.
and then area zero.
And then area, does it have to be area zero?
No,
Uh, any area that it's in, right?
right.
Any area that it's
But
in.
zero is the backbone.
Yeah. So now this is the second command. So now again, we know we're following a pattern here. So what does this command accomplish? So I go and I type this command. What? No, so we've explained what
It
this command
advertised
accomplishes. So it says
the network and then
advertises which network?
the present network
So is it the network that you've
on the
typed?
router.
Is it the network that you've typed that is going to advertise?
Yes.
Advertises the network that you've typed. So again, we have another poll. Time for another poll. Shane, do you agree? And you can't say you disagree and then don't give us your own this time around. You have to give us your own. So you agree, okay? Nice one. That's a good way to to avoid further questioning. Just agree quickly. JM, what do you think? JM, do you agree or disagree? Advertises the network that we've typed. Well, I'll tell you why where I stand. I disagree. Well, you're right in the command. You're right in this one. But in terms of
Mm,
advertises the network that you've typed, that's not what this accomplishes.
okay.
So let's see what this accomplishes. So we get you to do this. We get you to type this command and do this. So Kevin, what we want you to do is we want you to enable OSPF on interface S10 and F00 on this one. Actually, before we do that, let me just quickly try to explain what it does. So what this does, it enables OSPF on any interface that is on the network that you typed. So it doesn't mean that that's the network that is going to advertise. What do I mean
Mm-hmm.
by that? Let me come here. So let's say this IP address is 10.1.200.1, right? This one.
Mm-hmm.
So let's
Yes.
say I go and I type network 10.0.0.0 and I say 0.0.0.255 and I go area 0. You know what this command will do? It will enable OSPF on this interface. And what's the reason? Because it matches this network, right?
Mm-hmm.
Will it enable OSPF on this other interface? Serial 1. Of course it will. Why? Because they all match this network. Because this network is 10.0, right?
Mm-hmm.
And prefix 8. So that is anything that has 10 in the first octet. So any
Yes.
interface here that has 10 in the first octet, it will enable OSPF on that interface. It doesn't mean that this is the network that is going to advertise. It's not going to advertise that network. This is just a network to say, look for any interface that is on this network and enable OSPF on that interface. So when OSPF is going to advertise, it's not going to advertise 10.0. What is still going to advertise? It's still going to advertise 10.1.200.0/24. That's still what's going to advertise. Yeah. But you get the point. So it's still going to advertise the normal network on the interface.
Mm-hmm.
But the only thing this command is doing is that look for any interface that's on this network, enable OSPF on it, and put it in this area. That's all that is doing. It doesn't
Okay.
define what is being advertised. So actually, let's try that. So instead of us going, because many people, whenever they want to, you know, do that for OSPF, they start going network 10.0 dot, okay, like in this case, 10.1.200.0, right? And
Mm-hmm.
then they start going the wildcard mask, right? They start going
Mm-hmm.
0 dot, sorry, they start going 0.0.0. Oh, sorry, this one, I'm wrong with this one, sorry. I meant to say 255, 255. So they start saying 0.0.0.255.
Mm-hmm.
But this one, it makes no difference whether you type this one or you type 0.0.0.0. It's still going to have the same effect because only one interface matches 0.0.0.0 or 0.0.0.255. And that interface is going to enable OSPF on it and put it in the area that you specified. I'm not sure if that is clear. Is that clear at all?
Mm.
Is it clear, Kerry?
I understand. All right. You're trying to say that once you enter that command,
Yeah.
it's going to register that network on. I'm not sure. Go again.
It's not going to register this network at all. So actually, let's do this. Let's go to, if I go, let's bring up our router. And let's go debug IP OSPF adjacency and debug IP OSPF LO. Yeah, OSPF LO events debugging. But not so if I go and I want to enable OSPF on this interface,
Mm-hmm.
I can go conft router OSPF 1 and I can go
Mm-hmm.
network 10.1.200.1,
Mm-hmm.
right? And then it says I need the wildcard bit, right?
Yes,
I
which
can
is
go
0.0.0.25, 255,
dot
sir.
255. You see, this command, it accomplishes the same thing as if I do .0.0.
Because the all zero means last
Match,
resort.
it means match
Match everything.
everything completely. So what that means is that OSPF will go to all these interfaces and say, which interface matches this IP address? Any interface that matches this IP address, I will enable OSPF on you and I will put you into area 0.
Okay.
So if I go and say 0.0.0.255, what OSPF will say is that any interface that
Network.
matches
Oh.
10.1.200. Whatever,
Uh-huh.
I will enable OSPF on you and put you in area 0. But how many interfaces on this router matches this one?
One.
Just one, exactly. So it doesn't make any difference whether you put, because it's not going to advertise this network. That's not the network it's going to advertise. So this one is just to say, so I think, we mentioned last week about when things are wrongly named in IT sometimes, where when we gave an illustration of saying, Windows, they have the system volume. but the system volume has the boot files. And then they have the boot volume, but then the boot volume has the system files. So it's the same thing. So they've put network here. So instantly our mind is thinking, oh, this is the network is going to advertise. No, that's not the network is advertising. What that simply means is that which network do I enable OSPF? Sorry, which interface do I enable OSPF on? So if I go 10.1.200, so actually like one best practice that people do, well maybe not best practice that people do, is just use 0.0.0.0 for all of them. So instead, for example, instead of me using multiple network statements, I can use one network statement to achieve the same thing. I can go network 10.0.0.0, right? I can go 0.255.255.255. So what will this one do? Any interface that matches 10 dot whatever, it will enable OSPF on it, right? And it will put it
Yes.
in area 0. How many interfaces match 10 dot whatever?
2.
Actually, 3 of them, including loopback.
Okay.
Although we'll get to that later, it's not going to enable it on the loopback by default. So these two, so basically it's just going to go and enable OSPF on these two interfaces immediately, just with a single command. But that does not mean that this is the network that is going to advertise. It will still advertise only the network on this interface. That's the thing that is still going to advertise. But this one is just basically, the whole statement is just basically to say, look for the interface that matches, look for any interface that is on this network and enable OSPF on it. Is that clear better now?
Yes.
So actually, let me just go. So there's also try another tricking. What happens if I go, so this says 10.0.0.0, right? And if I
Mm-hmm.
put question mark, say wildcard bit. What happens if I go 255.255.255.0? What happens?
It will only.
Because that's not a wildcard, that's a subnet mask. What do you think will happen?
It won't go through.
Actually, it will.
It will. Okay.
Yeah, so let's do that. So let's go area 0. You know what will happen?
But then it won't match his.
It will, because you know Cisco is actually much more intelligent. So from version 12.2, it will actually take your subnet mask and convert it to
But
wildcard
it will.
mask for you.
Oh, okay.
So actually, let's do this. So remember, we said that this command, it will enable OSPF on any interface that is on the network that you typed, right? And
Mm-hmm.
what that means is that it will start sending hellos out of that interface. So we are still on step 2. So it's like, yeah, you've enabled me. Now I'm going to start sending hellos out of that interface. So this is when the sending of hello starts. When OSPF is like, oh, I've matched an interface, I'll enable OSPF on it and I'll start sending hello out of that interface. So let's do this now. So if I go with this command, remember again, I'm typing here a subnet mask, not a wildcard mask, right? And if I
Yeah.
press enter, look at what will happen. Remember that we have debugging running, right?
Right.
Yeah, it says build router LSA area 0.
Instead, advertisement for router 0 with the router ID.
Yeah.
For
So
process
yeah,
1.
I'm not sure how this was. Yeah, that's why I missed my Wireshark. um, so debug IPOSPF. Can I just use debug IPOSPF event? Let's just go event. Let's see. Okay, so look at this first of all, before we continue. So if I do a show run, remember that when I enable this network statement, I type 10.0.0.0.255.255, right? Now, if we go to look in the
Yes.
running configuration, let's look at what we'll find there. Look at this. It has converted it to a wildcard match
Okay.
for us. Yeah. So
But that only happens on your router.
yeah, on from 10.2
So if you have,
forward, anyone that runs code 10.2 going forward. So that's 10.0.0.0. So anything that matches 10.0.0. So actually, this this doesn't really match anything. So that was my own mistake.
mm-hmm.
So that was a mistake because that doesn't match anything. Remember. So if I do
Yeah.
conf t, sorry, router OSPF one, and then go to, yeah. So this doesn't match any interface on that on our network. So I have to do no. So let me just do it the normal way. Yeah, I have to go remove OSPF. Yeah, let's go network 10.1.1 dot. Let's just enable it.
The 10.100.
Yeah, sorry, 10.1.100.1 and 10.1.200.1. So let's enable it on
That's the,
10.1.200.1 and let's just go
no, no, no. There's you have too
0.0.0.0.
much.
Oh, sorry. Thanks for that. 10.1.200.1, 0.0.0.0. And let's
Uh-huh.
put it in area 0. Now look at what will happen. The email will press enter. Enables it on it, start sending hello. That should be the next thing that should happen. Come on, 10.1.200.1. It exists, right? Or the interface, I hope the interface is not shut down. Interface do show IP interface brief. Yeah, it is shut down. Oh, is it not? Yeah, it's shut down and it's got no IP address.
Oh, I only configured router one.
No, I think because we reloaded it, remember?
Oh, yes.
Yeah, so I think it just lost all the configuration when it was misbehaving. So interface fast Ethernet 01, and let's go um IP address 192 dot, oh, sorry,
No.
10.1.200.1 12.5.255, and we're gonna get lots of events now. We have to switch off debugging, and then we go no shot. And then OSPF should start, and then we should, yeah, exactly. Can you see that?
Yes.
Instantly start sending
Yes.
hello. It's like, yeah,
Now it looks
hello.
like debug is done.
So if I go interface serial 10, and then to IP address 10.1.100.1 12.5 no shots, clock rate 64,000, bandwidth 64. Yeah, there we go. And we've enabled that. So yeah, so it's enabled OSPF on the interface and it's sending hello out. So we'll get to like the DR, BDR and everything later. So it's sending hello out of this interface now. So the hello that it's sending out, what is inside that hello? What exactly? This is where I
The
miss Wireshark.
the the
So
IP address or the
which
network
IP address?
for the network?
Ah, here we go.
No, for the interface. Oh, it's working.
Yeah, it's back now. So let's just filter out OSPF packets. Yeah, no, it's not working. I think it just does like, because we used normal capture, because I set this to normal capture. Wants me to set it to live traffic pack capture. Set, apply, okay, and then go stop capture, start capture. Let's see if that works. Yeah, for some reason it doesn't like that command. Okay, yeah, let's carry on. So yeah, so
So
now it's sending hello packet. So you said hello packet, you said it contains what? It contains the IP address. What else does it contain? Jane, what else does hello contain?
the subnet mask,
Yeah, subnet mask. IP address of what?
router ID,
Good one, very good one. Router ID. It identifies itself. IP address of what?
The interface.
Yeah, of the interface that OSPF is enabled on. Yeah, what else? Shane, what else? What else does the LO that OSPF is sending out? What else does it contain? Yeah, what else does it contain? Shane said, I'm not sure. Authentication. What else does it contain? Yeah. Any other ideas?
Mhm.
What
Nope.
what else does it contain? Any other thing that you think it contains? There's an important one that's missing.
Area.
Good one, Kerry. Good one. Area. What else? We'll get to
I was
that
just about
later.
to say that.
Well, yeah, we'll get to that one later, but let's just put that down. So hello packet is not it's more than just saying hello, are you there? It's more than that. Hello packet is like a list. It's like the router saying, okay, here's a list of my configuration. This list contains some important information and it contains some non-negotiable information. What does that mean? Yeah, all the information in the hello packet are important, but then it contains some that is like, I cannot negotiate on this configuration. Any router that I'm going to become a neighbor with must have exactly the same configuration as me. Otherwise, we're not going to be neighbors. So out of all this information, which ones do you think are non-negotiable?
Subnet mask.
Subnet mask, good one. So let's put a star next to it. Which one else? Which other one?
Router ID.
What is non-negotiable about the router ID?
It's not to change it.
No, it doesn't matter. OSPF doesn't care whether it changes or not. Here's what is non-negotiable about it. It has to be unique.
All right.
You can't come to me and say, oh, I'm 10.1.1.2 when my own voter ID is 10.1.1.2. It's like, no, sorry, we can't agree. It has to be unique in the area.
Mm-hmm.
So what else?
IP.
IP, no, because yeah,
Can okay. The hello. The dead timer and has to have the same time.
so LO and dead timer, important ones. What exactly does it mean when we say LO and dead timers?
I think the hello is how often it sends out the hello packets,
Good one.
and the dead time is if the if there's a disagreement,
Mhm.
that's how long before the adjacency is torn down.
Yeah,
Um,
you're right, but I'll make it a bit simpler. LO is like um because the way because OSPF is a link state routing protocol, right?
yeah.
What's the difference between link state and distant vector? What's the difference? Shane, what's the difference between link state routing protocol and distance vector routing protocol?
Mm, link state.
For example, RIP is
Link.
distance vector routing protocol. How what does RIP send out when RIP sends out an information? What RIP sends out is RIP will send out its entire routing table.
Oh,
So RIP will say, see, here is my entire routing table, all the routes that I've ever learned about. And it will send it to the next route and say, here is my entire routing table. And it's going to send it every 30 seconds by default. So every 30 seconds, RIP will say, here are all the routes I know about. Here you go. That's the information. Now, the bigger the routing
oh,
table, the bigger the information that it's sending.
the but OSP, but link state only send when there's a change. That's what
Exactly.
you're asking.
So in the
Okay.
beginning, they will all send all this information. and then they converge. So after they converge, that's the whole purpose of the hello. They don't send all their routing table every time. The only thing they'll be sending are hello packets to find out, are you still alive? Are you still okay? So like, hello, are you still there? 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 So maybe one time it sends, hello, are you still there? And then it gets no response. Now, every time it's sending, hello, are you still there? The death timer is exactly what it is. It's a timer. It is counting down. So it sends out an hello. So the death timer is going from, let's say from 10, and it's going 10, 9, 8, 7. And then when another hello comes in, it goes back to 10. And then it starts counting down again. 10,
Okay.
9, 8, 7. And then another hello comes in, and then it goes back to 10. And then start counting down again. 10, 9, 8, 7. So maybe an hello doesn't come, it starts going down. 6, 5, 4. Another hello doesn't come, 3, 2, 1, boom, that's it. I'm forgetting about you. I would let all the other voter that I know about, and I'll tell them this voter is dead. So that's the meaning of the dead timer. Hello timer is how often are we going to be sending information to find out if we're still alive. Dead timer is how long will we wait before I consider you're dead. That's what dead timer means. It means I'll wait for this long. If I don't hear any hellos from you, I'll consider you. So by default, LO timer. So that's another thing to talk about. This is a really big topic. LO timer by default, what are they?
What are they?
Yeah. So what is the default LO timer?
Oh, 10
10.
seconds.
It says 10 seconds. So Shane, do you agree with that? Default LO
And
timer,
30
10
seconds.
seconds. What? And
Yeah,
30
30 seconds.
seconds. So you're right. So default LO timer, or sorry, let me not use the word timer. Let me use the word interval. So default LO timer, it depends on which network. So there are four types of network that OSPF knows about. So let's go, we're on an interface now. Let me go IP OSPF network question mark. Look at this. OSPF is like, yeah, I know of four network types. These types: broadcast, non-broadcast, point to multi-point. Let's copy this. Let's go paste it there. So OSPF knows about these types of network. Broadcast. Broadcast network simply means things like Ethernet. Non-broadcast network, we'll get to that one later. Point to multi-point, and then point to point. Point to point, of course, we know what a point to point is, right?
Yeah,
Something like our HTLC, our
PPP,
PPP, yeah, good one. Non-broadcast, we say things like
frame relay.
relay, ATM, point to multi-point. What is that?
No idea.
It's the same thing.
Okay.
Same relay, ATM. So those are the four networks that OSPF knows about. If you're broadcast or if you are point to point, let's get this to broadcast or point to point. OSPF uses default LO timer of 10 seconds. If you are non-broadcast and point to multi-point, it uses a default timer of 30 seconds. 30 seconds. And here's how we prove that. So if I go back to the router, if I want to find out which LO timer this thing is using, how do I find out?
Show OSPF, IP OSPF.
Show IP OSPF. IP OSPF.
One neighbor.
So let's see one. So let's see. Do we have any information about our timers here? No.
No.
Any information about timers yet? No. So show
Mm-hmm.
IP. It's not protocol. Show IP OSPF. Um, it's not protocol. It's not database. Is well, we can say timers maybe. Show IP OSPF timers. Well, no, not even that. I need that's for another thing to complete it. We'll talk about that. Show IP OSPF interface. That's the command.
Okay.
Show
Okay.
IP OSPF interface. That's the command. Interface, and let's just press enter that way. So show IP OSPF interface, and it shows us all the interfaces that OSPF is enabled on. And here we have timer intervals. Hello 10, dead 40. This one we'll talk about wait and retransmit later. So hello timer 10, dead is 40. And this interface is on an Ethernet network, this one. Now this one, let's enable OSPF on this interface also, serial 10, so that we can see what OSPF will give to it. Let's go conv router OSPF 1 network 10 dot 1 dot 100 dot 1 0 area 0, and then it starts sending out its own hello too. And then if we do go back and go show IP OSPF interface, and then can you see it's also 10 and yeah. So by default, it uses a timer of 10 if it's broadcast, which is Ethernet, or point to point, which is ATL, TPTP, PPP. And um, by default, LO timers are 4 times the interval of um, sorry, dead timers are 4 times the interval of LO. So you can see that by default, this is 40, right?
Yes.
Yeah, so this is 40 by default. Let's just remove all our debugging. So let's go UL. So you can see that by default, this has a dead timer of 40.
Mm-hmm.
So here's the thing. I think that's probably where we'll pause for now. What do you think, Kerry? Do you think we should pause there for now?
Yeah, we can pause.
Because the whole point, the main point is that this should like steer up like in our studying. Like when we're
Mhm.
so at least we'll so that's one of the reasons why we're going slow, why we're not rushing anything. Because we can try to rush and jam everything through and then nobody understands anything. Or we can try to go
That's true.
really slowly and see how much we can really get to break things down. So it has all these, and then so I think we'll just stop here for now, where we talk about this one. So what we'll do is we'll probably, I was thinking we'll start AIG up next week, but it seems as if we're not going to start AIG up next week. Because actually, we're still on step 2, right?
Mm-hmm.
Guess how many steps we're going to? We're going to 8 steps.
Oh, wow.
And we've not even started talking about DR, BDR, elections, and all that stuff.
That's what I was starting to.
Yeah.
All right. I have a question for
Yeah.
you.
Yes, please.
Explain the boot sequence because I'm getting a little bit confused, right? Because you're saying the boot sequence of a router,
Mhm.
it goes to fla no, flash, it goes to RAM, flash, then the TFT, TFTP server,
Mhm.
and then NVRAM. Am I right?
Yeah.
Or or is it post, then the bootstrap, then flash, and then NVRAM?
It depends. Let me try to remember. This has been. I think it's Flash first,
Uh-huh.
then I think it's TFTP after that.
Uh-huh.
NVRAM doesn't NVRAM doesn't contain um your iOS. NVRAM,
That's if there's a problem,
yeah,
right? That's if there's a problem in the flash, it tries to get the running config. 'Cause it's a running config in NVRAM, right?
yeah. So you have the config, yeah, saved inside the NVRAM. It's saved inside the NVRAM. But so the process is when you start it on, I think it does the power on self test where it tests the
Uh-huh.
hardware, make sure everything is okay.
Uh-huh.
So I think the next thing that it does is
The
something.
bootstrap where it goes to get the booting info.
Yeah, exactly, which is like the configuration register. So it's like where can I find the iOS?
Mm-hmm.
So normally the iOS will be located. So if it finds so it's like where do I find the iOS? Then it goes to I think it goes to,
Flash.
yeah, I think so. I think it's Flash after that. I think it's Flash, then TFTP server.
Okay.
Yeah, I think it's Flash, then TFTP server. Then I think when that one is not working, that's when it can use the ROM. When you
Okay.
use the ROM on mode for recovery.
Okay.
Yeah, so it's yeah. Sorry, I don't have like too much of like a clear answer, but it's something that I can look up and we can probably mention next time.
Uh, look up and I'll look up because I'm doing the exam next week.
You'll be able, you think that they're gonna ask you that much questions on the boot process and all that?
I think the last time they did ask me something on the boot process,
Ah, okay. Yeah.
and
That might-
I think I got. I'm not even sure. You know, I'm just
Actually,
trying to.
let me bring up Google. Let's go to Google. So you can still see my screen, right?
Yes.
So let's go Cisco boot process. So let's go Cisco boot process. Um, let's see. Yeah, another flash time. Yeah, so the router is powered on. The bootstrap program in ROM runs posts. The bootstrap checks the configuration register value to specify where to load the iOS. So yeah, so that one specifies where to load the iOS. Um, after the I okay, yeah, it says by default, the default value of configuration register is 2102. The router first looks for boot system command in startup config file. If it finds this command, it will run boot system commands in order they appear in startup config. You locate the iOS. If not, the iOS image is loaded from Flash. If the iOS is not found in Flash, Bootstrap can try to load the iOS from a TFTP server or from ROM. After the iOS is found, it is loaded into RAM. The iOS attempts to load the configuration file startup config from NVRAM to RAM. If the startup config is not found in NVRAM, the iOS attempts to load the configuration file from TFTP. Yeah, so perform post load bootstrap. So locate iOS in the flash memory of TFTP server. So if it finds it, it loads the iOS. Then locate the configuration file in NVRAM, TFTP or console. Then load the configuration file. So I think this one is like much more clearer.
Yeah.
So it does the power on self test and then does the bootstrap. Then
Uh-huh.
locates the iOS. So it is flash first,
If it's not
followed
in
by
Flash, then it goes to the
TFTP.
server.
Yeah.
Mm.
So flash, then TFTP, then flash TFTP ROM. So if Flash doesn't work, then TFTP doesn't work. No iOS in Flash, no iOS in TFTP. Then it can use the
Then go
ROM.
to NVRAM.
Yeah, where it
Okay.
uses the ROM on.
So it
So it's not
is
the NVRAM. So
post
it doesn't load
bootstrap
it never loads the iOS in NVRAM. So
Flash.
NVRAM is only for configuration file.
Okay.
For example, if I go to this one and I go Q show Flash. Yeah, because it's GNS3. um, yeah, so yeah, it is GNS3. So it doesn't operate like it's the proper iOS, but it doesn't because they did some hacking to make it work.
Mm-hmm.
So but normally I think what the other thing that the other guy mentioned, I think that one is much clearer. So it boots up first,
Mm-hmm.
then it does the post. Then after doing the post, it loads the iOS, load iOS from Flash. If it doesn't find
Mm-hmm.
iOS in Flash, it will load iOS from TFTP.
Yeah.
If it doesn't find iOS in TFTP, then it can load into something called the Ramon mode, which is like a recovery mode.
Okay.
Yeah. Then, but if it finds the iOS in Flash or in TFTP, then the thing is, it has to load the configuration from NVRAM. This is what this guy mentioned. Load the configuration file. So the Bootstrap program locates the Cisco iOS software and loads it into RAM. Cisco iOS files can be located in one of three places: flash memory, a TFTP server, or another location indicated in the startup configuration file. The Cisco iOS software loads from flash memory by default. The configuration setting must be changed to load from one of the other locations. So then after that, locate and execute the startup configuration file or enter setup mode. Yeah, so I think that's like really helpful. Is that helpful, right?
Yes, yes,
Yeah,
yes,
yeah.
yes.
So that's the Roman one. So flash TFTP, then the Roman, which is like a recovery mode. It is this one that you can load to if you want to recover things like do something like password recovery or things like that.
Mm-hmm.
Yeah. Okay. So all the best in your exam, man. All the best.
Thank
Yeah.
you.
I would say one thing. I know one thing that gave me confidence was I just did like a lot of labs because at the end of the day, when I did a lot of labs like before the exam, and that gave me like some confidence. So even like when you're doing your revision, if you have the chance, maybe just take some time to
Yeah.
still do
I'm
something.
gonna do some labs. I'm doing labs. I
Yeah,
have some labs that I'm doing,
yeah,
and I have some practice questions that I'm answering,
yeah,
and that is what's helping me.
yeah,
So I think I just need to know my show commands,
uh-huh,
the ones that are, useful so that I can get the relevant information that I need when they show me whatever troubleshooting.
yeah,
Then we'll be able to answer those multiple choice questions.
yeah.
So that
Mm.
should be good.
Yeah, all the best. Yeah, if you need anything, just you can send me an email or something.
Okay, I will.
Yeah,
Thank you so much.
yeah, no problems. Yeah, yeah. See you later. Yeah, have a good evening. Yeah, bye
All
for now.
right, see you. Bye.
Yeah.